for tonight, pages 592, all, and pages 606 and 607, evens only. Bam! Repeat that again. Bam! Let's go. So once again, please keep up with your home plate. Stop copying from people. All right. We good? Yes, this is good. All right, good. So we're continuing on with sequences. Tonight's practice will be pretty good in order for us to move on to just series, and then from there we're going to end with sequences by tomorrow, hopefully. Since you already did the home play over the weekend, you had plenty of practice with yesterday. All right. Our objective for today, I can identify arithmetic and geometric sequences. Once again, I can identify arithmetic and geometric sequences. And as you notice, we're still continuing on from the home play I left you over the weekend. For those of you that weren't here on Friday, hopefully you use your social media to get a hold of someone on Twitter or Snapper, or Instagrammer, Kicker, WhatsApper, no, all those. And they told you exactly where to go, right? Yes, Mr. Q. All right, good. All right. Or what's the other one? The TikToker. So, let's see. If you remember from the notes. Arithmetic and geometric sequences. Without looking at your notes, write me a definition in your own words. Actually, before that, tell your neighbor, share some of your thoughts in regards to this definition. All right. This is what I hear. I heard somebody said that it's a list of numbers. Yeah, I heard that. Some of you said sequence. Well, yeah, that's a list of numbers. And also some of you said that they have a pattern. Yes. So the definition says a list of numbers, each number known as a term, and they often have a consistent pattern known as a common difference or common ratio. But like I said, you already have these notes. What am I talking about? And I gave you guys these two examples, 1, 5, 9, 13, 17, 21. And the other list of numbers were 1, 5, 25, 125, and 625. And I said in the video, I'm going to start with arithmetic sequences. So according to the definition, it's a list of numbers. Did I have a list of numbers here? Yes. The second thing is that it has a consistent pattern. So let me look at this. Does it have a consistent pattern from here to here, from here to here, from here to here? Yes, it's adding 4. That consistent pattern for arithmetic sequences is known as the common difference. And notice the word difference with the letter what? D. And why am I putting it in quotations? Because the letter D we use for the form or the formula that you memorized, right? Good. So here the difference, or the D, is positive 4. Now let me go to geometric sequences. Once again, according to the definition, it's a list of numbers. Do I have a list of numbers here? Yes. Often has a consistent pattern. So let me see if it has a consistent pattern. Here. Yes, so the consistent pattern is multiplication times 5. Difference will always be addition or subtraction. Let me label that right here, addition or subtraction. So that means for geometric, it will always be multiplication and division, but division, we can rewrite it as multiplication because of the definition that we found with quotients. So what is this in geometric sequences? Is called common ratio. And notice the word ratio starts with what? The letter R, and that's the letter that we need to memorize or to remember, because that's the one we use for our formula. They're like, Mr. Q, we got this. We took notes on this. Why are we saying that again? Just to catch some people up that didn't watch the video. None examples. 1, 3, 6, 8, 16, 18, 36. So let's see. Is it a list of numbers? Yes. Does it have a consistent pattern? Let's see, from here to here, 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 here to here. Looks like they're adding 2. Do I add 2 here? Nope. But here, yeah, we add 2. We add 2. Oh, I see. They're multiplying times 2, multiplying times 2. Is it only one consistent operation or pattern throughout? No, that's why this is not either arithmetic or geometric. Let's do always. Yeah. So Anthony is correcting us. He said, Mr. Q, come on now. Put always. Thank you, Anthony. So, in the video I said, hashtag this. What is the 2 things that a sequence needs to have? Well, it has to have a list of numbers, and it has to have a what? Consistent pattern. All right. So we're good with that, yeah? Yes, thank you. All right. From there, I went ahead and presented steps for explicit and recursive. We're not going to write those. You already have those. But I'm going to move on to show you an example that I addressed. And I started with these. Look at this one. You don't have to copy this. You already have this from the notes. It says find the first 4 terms. For the first 4 terms, I said create a table, n, f of n. And they want us to do the first 4 terms, 1, 2, 3, 4. So I use my given function, and I'm going to substitute the first value. F of 1 equals 1 squared plus 1. F of 1 equals 1 plus 1. F of 1 equals 2, and that goes right there. And one thing that I mentioned in the video, I said, do you guys notice that after we substitute here, nothing changes on the left side? Yes, because all we're saying that we're working on that term, which is the only thing that changes, the right side. We work throughout because that's the function that's happening when we input that value. So if I was to input the next value, which is 2, 2 squared is 4 plus 1 is 5, 3 squared is 9 plus 1 is 10, 4 squared is 16 plus 1 is 17, and you can show the work that you already have it. Just recapping. So far so good, yes? Yes, Mr. Q. And I give you another one which was something like this, an easy one, yeah. All right, copy this next one, example 1 super Q, and it reads, find the 8th term if the domain is all whole numbers greater than 0. And the given function is f of n equals 2 times n squared plus 6. Copy that. So, for this one, some of you started doing a table n f of n, and you got 1, 2, 3. No, that's crazy to do all that work all the way to number 8. Which one are they asking us to use only? 8. So you just do dot, 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 8. And you just go straight to this one and substitute that value to get your output. So what would I write? F of 8 equals 2 times 8 squared plus 6. F of 8 equals 2 times 64 plus 6. F of 8 equals 128 plus 6. F of 8 equals 134. And that goes right there. Like, Mr. Q, come on now. Crank it up a notch. This is too easy. And yes, and by the way, all these rules that I've been giving you of the functions, these are known as explicit functions. Today, we're going to learn how to write explicit functions. In the video, we only did recursive. That's why I'm revisiting these. And let me show you the recursive one. For the recursive, I said there's, for arithmetic and for geometric. And I gave you this for this one and this for this one. So look at the arithmetic sequence. F of n equals f of n minus 1 plus d. For geometric is f of n equals f of n minus 1 times r. Tell your neighbor what's the same for both. Why is it going to be easy to memorize this form? Recursive. Very good. Because the beginning is the same for both. F of n equals f of n minus 1. What's the only difference for both? That for arithmetic we put plus b, and for geometric we put times r. Okay? Also, what else do we know from here? Well, Mr. Q, I know that this piece right here is the prior term. What does the word prior mean? The term before. So if I was to ask you to find me the sixth term, according to this form, we need which term? The fifth, because this says prior, so I would need the fifth term. If I was to ask you for the 23rd term, if we're using these, what term do I need in order to find the 23rd term? We need the 22nd term. We need the term prior. That's what f of n minus 1 means. But of course you guys saw the video. What am I talking about? So then from there, I gave you guys a practice one, which looked like this. And I said, all right, so let's find out what's happening from here to here, from here to here, from here to here. And everybody said that we're doing what? Adding 4. If we're adding, that means that it's a arithmetic. That means this is our D. If that's true, then we know what form to use. Is that correct? F of n equals f of n minus 1. And then at the end we do what? Plus d. But is that my form, my rule? No, it says write the rule. This is not my rule. The rule needs to include the new value, which is what? 4. So we would write f of n equals f of n minus 1 plus 4. This is my rule. And from there to find the next two terms, this is term 1, 2, 3, 4. I need which terms? 5 and 6. So to find term 5, I'm going to substitute that in here. So it's going to be f of 5 equals f of 5 minus 1 plus 4. F of 5 equals f of 4 plus 4. F of 5 equals, what is f of 4? F of 4 is 21. And bring down the plus 4. F of 5 equals 25, and that goes right there. Am I done? No, I needed the what? The sixth term. So that means I need to do the same, but now for the sixth term. So I'm going to start over here. F of 6 equals f of 6 minus 1 plus 4. F of 6 equals f of 6 minus 1 plus 4. Oh, sorry. What is 6 minus 1? 5. F of 6 equals, what was f of 5 we found? F of 5 was 25 plus 4. F of 6 equals 29. There it is. Now, how does this look in Algebra 2? Now the book presents these like this. They're going to present them in tables. This is our n, and this is our f of n. Now, some of you are like, Mr. Q, why can't I just follow the pattern and write the next numbers? Because that's for third graders. I've done this with third grade kids. Are you in third grade? No, that's why you need to show me the work. But we have this, right? We have this in our notes from the video. Yeah, good. Good. All right. So that was what? Recursive. And this was an example of an arithmetic one. Let me show you an example of a geometric. Bless you. Look at it. What's happening from here to here to here to here to here to here? Times 4. If it's multiplying, then this is considered R what? R. R what? R, like pirates. R. No. So we write our general form, f of n equals f of n minus 1 times r. So my rule is f of n equals f of n minus 1 times 4. And the rest is the same thing as the other. You do the work and so on and so forth. Yes? Let's do this. Tweezy. Crank it up about 5 notches. All right? So this is recursive. So what did we know? That we need to learn, we need to memorize both forms, arithmetic and geometric for recursive. Well, today, I'm going to give you the new one, which is the explicit general form that you need to learn. Here it goes. Take notes of this. For the explicit arithmetic sequence is as follows. F of n, bless you, f of 1 plus d times n minus 1. Once again, for the explicit rule of an arithmetic sequence is f of n equals f of 1 plus d times n minus 1. Now, so that you understand what we're looking at here, here it goes. I want to start with f of 1. This piece tells us that we substitute in here the first term of the sequence given, of the sequence. First term of the sequence. What does the letter D stand for, everyone? Very good, the difference. That's why this is an arithmetic. It's the difference. All right, and what does the N represent? Right here and right there. The N represents the term worked on. Whichever term you're working on, you substitute in there. Or the term to be found. Term worked on, substitute in there. All right. Now check this out. The book introduces, instead of writing f of 1 as our first term, the book presents it like this. Look up. Like this. A sub 1. That's just another form of writing term 1. So make sure you label this on your notes. Make sure you put a little arrow. Keep that in mind because the book's going to reference to the first term as A sub 1. Pretty straightforward, yeah? All right, so that's the arithmetic sequence. Now let me give you the explicit rule for geometric sequence. Here it goes. F of n equals f of 1 times r and r to the n minus 1 power. F of n equals f of 1 times r to the n minus 1 power. Once you copy that, label each part and talk it over your neighbor. Let them know what each part means. Copy that and I'll give you some time. Go. All right. So, of course you said that f of 1 is what? Term 1. R stands for what? Ratio. And the n's are what? The term that you are working on or the term to be found. Okay? Now, why am I giving you these? Because you need to memorize these. Not only these, but the previous one. What were the previous ones? The recursive. What was the beginning for both? F of n equals f of n minus 1 for both. It was the same. F of n equals f of n minus 1. However, this one is what? Plus d, and this one times r. You need to memorize these 4 because that's what they're going to ask you for. What is it there? before they're going to ask. Never mind. All right. All right, copy this one. Example 3. It says, given the sequence, write the explicit and recursive rule and use the rules to identify the next two terms. Or two terms. Should have put the end there. Example 3. Given the sequence, write the explicit and recursive rule and use the rules to identify the next two terms. Here goes the pattern or the list of numbers. We have 34, 30, 26. So we're going to do this one together so you guys can see the process. We already did a lot of stuff and it's going to come together all together. So here we go. Since we're already in Algebra 2 and now they're going to present these instead of just giving you a sequence like this, most of the times they're going to give you a table. So can we make this into a table? Yes, Mr. Q. All right, so then we draw here and here. This is n, this is f of n. So what would we label the first number? 1 and then 2 and then 3. And we need to find the next two terms, which means I need to label this 4 and this one 5. So they want me to write the explicit and recursive rule. But wait a minute, I don't even know if it's arithmetic or geometric. How can I find that out? Talk it over your neighbor. How can I find out if it's arithmetic or geometric? Very good. By finding the pattern, what's happening from here to here, from here to here? Well, what? Subtracting 4. So if we're subtracting, that means it's an arithmetic. That means this is our D. Now that you have that, now you can think of the two forms. Let's start with recursive. What was our recursive form? F of n equals f of n minus 1 plus d. So I'm going to write my recursive rule using this d. So then it's f of n equals f of n minus 1 minus 4. This is the what? Recursive. Okay. But they want us to find also the what? The explicit. All right. So how's the explicit for arithmetic? F of n. And the first term always, we start with the first term, f of 1. And then plus d times n minus 1. So now let's just substitute the d value in there. So we get f of n equals f of 1 minus 4 times n minus 1. And this is our what? Explicit. Okay. Bye, Cindy. All right. So, let's get to work. Which one do you want me to use? This one or this one? Recursive or explicit? Let's try the explicit. We haven't tried this one, have we? All right. So here we go. So I'm going to substitute my first term, which is 4. So I'm going to do f of 4 equals. However, what is our first term? First term is 34. Bring everything else down. Negative 4 times, n was what again? Which one are we working on? 4 minus 1. So f of 4 equals 34. Negative 4 minus 4 times, what is 4 minus 1? 3. F of 4 equals 34 minus 12. So f of 4 equals 22. That goes right there. Am I done? No, I need to find the fifth term. But before I do, I need to find out if I got the correct one now using the recursive. Yeah, let's go. Let's go. F of 4 equals f of 4 minus 1 minus 4. F of 4 equals f of 3 minus 4. F of 4 equals, and by the way, look up, what is f of 3? f of 3 is 26 minus 4, so f of 4 equals 22. Did we get the same thing? We should get the same thing because it's the next number in the pattern. We're just using different forms. Am I done? No, you need to find me the fifth term. Show me the work for the fifth term using both. I already showed you the process. I'll give you some time. Copy that and go. All right. Any questions? Anyone? All right. So let me show you now the fifth term using the explicit again. So do I need to write this top one? No. The second one? No, I can continue from here and substitute the f of 5, right? F of 5, so I'm using this one. F of 5 equals, what is f of 1? 34 minus 4 times 5 minus 1. F of 5 equals 34 minus 4 times 4. F of 5 equals 34 minus 16. F of 5 equals 18. And we got that? Yeah? However, let's do now using what? The recursive, our favorite one, yeah? So I'm going to start here. And I'm going to write f of 5 equals f of 5 minus 1 minus 4. F of 5 equals f of 4 minus 4. F of 5 equals, what was f of 4 we said? 22. So 22 minus 4. F of 5 equals 18. Show me if I'm struggling through are with these. Yeah. Now, I know some of you have the question in your mind saying, Mr. Q, are we going to have to do both forms for home play? Whatever they're asking you to do on the page, that's what you're going to do. I'm showing you both ways because sometimes they're going to ask you either for the explicit or for the recursive. Okay? All right. So that was an example of an arithmetic using recursive and explicit. Let me show you an example of a geometric. Look at this one. Copy that and see if you can write me the form. Yes. You don't need the instructions anymore. Just copy the sequence. 1, 3, 9. And here, let me help you out. There you go. That's pretty good, right? To get your table started. Bam. All right. So you should have done this, and that. And f of n. 1, 2, 3. And they need the next two terms. So we write what? 4 and 5. Okay. So how can we write our rule if we don't even know if it's geometric or explicit? Or arithmetic? What do we need to find out? The pattern, yes? So what's happening from here to here to here to here to here? Times 3. If it's multiplying, then it's a what? A geometric, so it's an R, like pirates, R. Or like tigers, R. Bam. See what I did there? Anyway. Recursive. F of n equals f of n minus 1 times r. And then our rule would be f of n equals f of n minus 1 times 3. Now that we substituted the r. How about our explicit? F of n equals f of 1, what else? Times r. This is the one that's kind of trippy because the exponent is what? N minus 1. So just be careful with this one, okay? So now let's substitute the value of r. So it's f of n equals f of 1 times 3 n minus 1. Find me at least the fourth term using both, please, so we can move on. Fourth term, so I substitute that in here, f of 4 equals, and here f of 1 means what? The first term. What is our first term, everyone? 1 times 3, and then we're working on the fourth term, so instead of n, I would put 4 minus 1 as the exponent. So therefore, this is f of 4 equals 1 times 3 to the third. F of 4 equals, do I need to really write the 1? No. So what is 3 to the third? 27, and it goes right there. Let's see if I get the same number using the recursive. F of 4 equals f of 4 minus 1 times 3. F of 4 equals f of 3 times 3. F of 4 equals, what is f of 3? F of 3 is 9 times 3, so f of 4 equals 27. And if you got that, okay, shall we finish for that kind of sample? You got this, yes? All right. Once again, you need to learn both ways. You need for arithmetic and geometric, you need what? Recursive and explicit. All right, let's crank it up a notch. Yeah. So look up, copy the sequence, and I want you to copy the bold instructions down here. Example 3, Super Q says, given the sequence, write the explicit recursive rule and use the rules to identify the next two terms, but also identify the 100th term. Yeah, let's go. The sequence given is 11, 5, negative 1, negative 7. So, here it goes. 1, 2, 3, 4. They want the next two terms, which is 5, 6. But then they want the what? The 100th term? You're like, what? Yeah. I know, right? All right. So let's see. N, f of n. So what do we need to find out? The pattern. What's happening from here to here to here to here? Subtract 6. So if we're subtracting, this is response to what? To the letter D. So it's an arithmetic. So what are my forms? F of n equals f of n minus 1 plus b, and f of n equals f of 1 plus b times n minus 1. And now I just substitute the negative 6. F of n equals f of n minus 1. Substitute negative 6 for the d, so it's minus 6. And for this one, f of n equals f of 1 minus 6 times n minus 1. So there you go. I have my both forms, recursive and explicit. Question, look up really quick. Write your utensils down. Look up, look up, look up, look up. They want us to find the 100th term. What does that mean if I use my recursive? Don't I need like the 99th term to substitute in here? So to find the 100th, I need to find the 99th. But I don't have the 99th. What does that mean? Then I need to find the what? 98, and then 97, and then, ain't that crazy to go from 6 all the way to 100? So question to you, which of the two would you use to find the 100? Would it work with this one? Let's find out. Let's see. F of 100 equals, what is the first term? 11 minus 6 times 100 minus 1. f of 100 equals 11 minus 6 times 99. F of 100 equals 11 and minus, what is 6 times 99? That's 594. F of 100 equals, that's negative 583. Oh, I didn't even have to find the other one. This is negative 583. So you're going to have to start making some of those decisions with a home plate when they ask you to find this extreme number way out there, which rule you're going to use, either recursive or explicit. Right, Allie? Let's go. And last but not least, look up. What do we have here? Fractions, or it's division, right? Division by 3. If we're dividing by 3, look up. If we're dividing by 3, we cannot write it as divided by 3. We need to write it as multiplying times 1/3, or if it's a negative. And last but not least, hold on, last one. What does a sub 1 mean? A sub 1 means what? First term, and R, that it's a geometric sequence, and you know what to do from there. Have a good one, guys. Enjoy your home play. See you guys tomorrow. There is tutoring today. It's free. Home play, once again, pages 592 and 606 through 607, even only. Bye. Yeah.